All right, let's get right into it. Today, we're unlocking the engine that's driving this entire AI revolution, large language models. You've definitely heard the term, you've seen the headlines, and now we're going to break down exactly what they are and how they actually work. I mean, it can feel like pure magic, right? You type in a question, and boom, this coherent, creative, and sometimes, well, startlingly human answer just appears. But it's not magic, it's technology. So, okay, let's dive in and really see what's going on under the hood. The first thing to really get is that this isn't some far-off futuristic concept. Nope. Most of us have already used large language models, or LLMs, probably without even thinking twice about it. Think about it. Maybe you've used an AI to help you draft an email, or summarize a super long article, or even create a totally unique image just from a few words. These tools, they might feel different, but they all share the same powerful foundation. They're the cool apps built right on top of the core engine we're here to understand. So let's pull back that curtain. What is this engine? It's time to get to the very heart of it and define what a large language model actually is. So here's the core definition. An LLM is an AI system that's been trained to understand, to process, and to generate human language. And the key word here for sure is large. It's talking about two things: the absolutely massive amount of text data it learns from, and the enormous complexity of the model itself. And when we say large, we mean mind-bogglingly large. A model's complexity is measured by its parameters. You can kind of think of them like internal knobs and dials the AI tunes to weigh connections between words and ideas. Just to give you a sense of scale, GPT-4 is estimated to have around 1.8 trillion of these parameters. That's the kind of scale you need to even begin to capture the incredible nuance of human language. Now, what's really wild is just how recent all of this is. This entire field basically got supercharged in 2017 with the invention of a brand new architecture called the transformer. Almost immediately after that, in 2018, the first modern LLMs popped up, and by the 2020s, they had just exploded into the powerful mainstream tools we see everywhere today. So, that's the crucial piece of the puzzle, the transformer. It is the secret ingredient, the fundamental innovation that really unlocked the potential of modern AI. It completely changed the game for how machines process language. Okay, so before 2017, AI models read a sentence pretty much one way, from start to finish. They were unidirectional, which means they only considered the words that came before the word they were looking at. Transformers, well, they changed everything by being bidirectional. They can look at the entire sentence at once, forwards and backwards, to understand the true context of every single word. It's a huge difference. Now, I know this diagram looks complex, but stick with me. The key idea is pretty simple. On the left, you've got the encoder, which reads your text. On the right, the decoder writes the response. The real magic, though, is in those boxes labeled multi-head attention. This is the part that lets the model look at an entire sentence and figure out which words are most important to which other words. It's how it knows that in "the cat sat on the mat," the word "sat" is deeply connected to cat and mat. That's where it gets its deep contextual understanding. So how does a model actually learn all this? It's basically a two-step process. First up is pre-training. This is where the model is just set loose on a gigantic chunk of the internet. It's called unsupervised learning. It just learns the rules, the patterns, the connections of language, all by itself. Then comes fine-tuning. This is where humans step in to guide that general model, to specialize it for a specific job. Like, say, being a helpful and harmless job. Okay, so we've looked at the engine and how it's built. Now let's talk about what that engine can actually do. What are the real-world applications and advantages that are changing, well, everything? The list of what these things can do is just vast, and it's growing all the time. They can generate human-like text, everything from poems to computer code. They can do high-level language translation. They can analyze the sentiment of a product review, power conversational chatbots, and even, finish your sentences in an email. And this brings us to why this technology has been adopted so incredibly fast. The advantages are just so clear. It's a massive force multiplier for anyone creating content. It makes us way more effective at any task that relies on language, and it boosts efficiency by automating the kind of monotonous work that frees us up to focus on more important stuff. But, and you knew there was a but, as with any technology this powerful and this transformative, it doesn't come for free. We have to look at the other side of the coin, the pretty significant challenges and responsibilities that come along with it. You already know the rest of that phrase, right? This incredible power to reshape how we work and communicate brings with it some very, very serious considerations that we just can't afford to ignore. And here are some of the biggest ones. These models are often black boxes, which makes it super hard to understand their reasoning. They can reflect and even amplify biases found in their training data. There are major privacy concerns over how that data is collected and used. They have a huge environmental footprint because they cost so much energy to run. And right now, the whole field is dominated by just a handful of big tech companies. So the crucial point is this: large language models are here, and their influence is only going to grow. As our source material puts it, the conversation we need to be having isn't just a technical one, it's a societal one. It's about how we all want to integrate this technology into our lives. There is so much at stake, and it's a debate we all need to be a part of.